In the last video, we found out how to compute the number of factors for a number. Extending that logic, this could be another kind of question which will ask you to find out in how many ways can you express a number as a product of two numbers. Let's quickly run through this question. In how many ways can 48 be expressed as a product of two positive integers? See, the question is asking in how many ways can I write 48 as an A into B? It's quite evident that both A and B will have to be factors of 48. So our starting point is going to be listing down the factors of 48. These are all the factors of 48. We've already seen it with the earlier video. Let's quickly find out in how many ways can we write it as a product of two numbers. It could be a 1 into 48, which is one way. 2 into 24, which is the second way. 3 into 16, third way. 4 into 12, fourth way. And 6 into 8, which is equal to fifth way. How many factors did 48 have? 48 has 10 factors. Each of these, for A being 1, B can only be a 48. It cannot be anything else. So we have 10 factors. Each factor is clearly tied to one other factor and only that factor. Your 1 into 16 cannot give you a 48. Only 1 into 48 can give you a 48. So how many pairs can we make out of these 10? 10 by 2 will be able to make 5 pairs. So the number of ways in which we can express 48 as a product of two numbers will be the number of factors for the number divided by 2. Basically capture it in this slide. How many ways can we express it? These are all the ways in which we can write it. 1 into 48, 2 into 24, 3 into 16, 4 into 12 and 6 into 8. Number of factors for 48 is 10. In how many ways can we express it as a product of two numbers? Half of that, which is 10 by 2, which is equal to 5. So here is a formula. If you want a formula, number of ways of expressing it as a product of two positive integers is number of factors divided by 2. Let's look at a couple of examples to get some practice. In how many ways can we express 72 as a product of two numbers? In how many ways can we express 36 as a product of two numbers? Starting point is computing the number of factors. So how do we go about it? What we learned in the last lesson, let's put it to use. Let's prime factorize these numbers first. Prime factorize 72. It is 8 into 9, which is equal to 2 cube into 3 square. The method to find the number of factors is increment the powers of each of these prime factors by 1 and multiply it. So 3 plus 1 is a 4 and 2 plus 1 is a 3. So we'll have 12 factors for 72. So in how many ways can we express it as a product of two numbers? 12 divided by 2, which is equal to 6 ways. Run through the same exercise with 36. 36 is a 6 into 6. 6 is a 2 into 3. So this is going to be a 2 into 3 square. So 2 square into 3 square. Increment the powers. The power of 2 is a 2. When we increment it, it becomes 2 plus 1. And when we increment the power of 3, that becomes a 2 plus 1. So this is a 3 into 3. We have 9 factors for 36. Number of ways in which we can express it as a product of two numbers is 9 by 2, which is a 4.5. That sounds absurd. How can you express something as a product of two numbers in 4.5 ways? It can either be 4, can be 5, can be 10, but 4.5 does not make sense. Let's quickly check out why it's happening the way it's happening. Let's list down factors for 36, right? And see in how many ways can we write it as a product of two numbers. 1 into 36, yes. 2 into 18, 3 into 12, 4 into 9. All of these are okay. There's one other, which is how we started this, which is a 6 into 6. Look at these 4. The A and B were two different values. If A is 1, B is 18. If A is 36, if A is 2, B is 18, so on and so forth. But in this particular case, both the A and B ended up, ended up being the same value because 36 is a perfect square. Perfect squares are numbers which are essentially a number multiplied by itself to give you an answer. 6 into 6 gives us the 36. So here we don't have an A into B. We have an A into A. So how many ways does 36 have in which we can express it as a product of two numbers? These 4 plus the 1 where the number multiplies with itself to give you a 36. So here the answer is going to be 5 ways. The adjustment we need to make to our formula is basically number of factors plus 1 by 2. When will we do this? We'll do it whenever the given number is a perfect square, or in other words, whenever the number of factors ends up being odd. So we'll tie these last two bits which I said. The number is a perfect square. We realize that the number of factors for the number is going to be odd, primarily because Every time an A and B are two different values, we have even number of factors. When there is the A and B are one and the same, that's going to be one single value. So many even numbers plus one odd number is going to give you an answer which is odd. So perfect squares will always have odd number of factors. So captured it in this statement. Perfect squares have an odd number of factors. The reverse is also true. If you figure out that a number has got odd number of factors, then it has to be a perfect square. So I'll reword it this way. An odd number of factors will exist for a number if and only if the number is a perfect square. We looked at the logic by looking at the fact that there is one number which multiplies with itself, therefore odd number of factors. Let's also look at the logic, revisiting it from the prime factorization perspective. Right? What did we say prime factors of perfect squares will be? The powers of prime factors of perfect squares will all be even. Just take this 36 itself. 36 is a 2 square into 3 square. How do we compute the number of factors? We incremented these. So I'm going to increment an even number by 1 and I'm going to increment another even number by 1. Even number plus 1 is going to be odd. So odd into odd has to be odd, which is why the number of factors for a perfect square is always odd. When incremented by 1, even powers will become odd. Product of odd numbers is always odd. Let's wrap this entire thing with one more example. In how many ways can 36, same number, be expressed as a product of two distinct positive integers is this variant? Let's list down whatever we had. 1 into 36, 2 into 18, 3 into 12, 4 into 9. In all these 4 instances, the two factors were distinct. Whereas in this case, 6 into 6, the factors are not distinct. So how many ways do we have? We don't have 5, we have 4 ways. So one more adjustment to the formula. The question is, in how many ways can it be expressed as product of two distinct numbers? Then it is number of factors minus 1 by 2. Two numbers, number of factors plus 1 by 2. Two distinct numbers, number of factors minus 1 by 2.
Check out the related videos and remember to subscribe to the channel. What's more, let's make scoring Q51 GMAT a reality. Sign up for the most comprehensive and affordable online GMAT quant course at gmat.visaco.com. That's again gmat.visaco.com.